Okay, in this video, we're going to take a look at graphs and try to figure out what the quadratic equation is. So essentially solving for A, B, and C of this quadratic equation. We're going to add one additional step to take it from the graph to points that we know lie on the graph. And then after that, we can use one of the methods that we've learned from in one of the previous videos. So we have three examples we're going to look at. I'm going to look at the first one with you and then walk you through the second and third one, where I want you to use the third one, pause the video, and try to work it out on your own. So I've worked out part of this first one. Now this is our graph that we're given for this first graph, okay? One of the things we can do is identify points on this graph. So this first set of steps I took were identifying 3 points. I identified the point 0, 0 at the origin, the point 4, 0 crossing the x-axis at the second location, and the point 2, 2, the maximum of this graph here. Now, a couple things that are interesting. So once you find those 3 points, then it's basically plugging them into the quadratic equation. So I did that here. I did that for point 2, and I did it for point 3. All right. So interesting thing to note is for when it crosses the origin, the 0, 0 point, your y term drops out, your a and b term drop out because x is equal to 0. So all you're left with is c is equal to 0, which means no matter if this is crossing at a maximum, a minimum, or just a random point like this is shown here, c is equal to 0. So when you have a quadratic equation and c is equal to 0, you know that that graph goes through the origin at some point. You also know when you have a graph that goes through the origin that you already know that c is equal to 0. So that makes things nice and clean, right? So here I cleaned up this third equation in terms of b, and then down here I plug in this b term into my equation 2. That's why this 0 is equal to 16a plus 4 times, here's my b term, 1 minus 2a, and solving that out, I get a is equal to negative 1/2. Makes sense that it's negative because we have our parabolic curve going in this direction. So we have a maximum. So I do expect a negative to show up here, as we talked about in the last video. All right, and the very last step in order to solve for b is just plug it into this equation. Then solve for b. We plug in b is equal to 1 minus 2 times a, negative 1/2. So this is equal to 1 plus 1, or just 2. All right, so this is my b term here. All right, so now I can plug those back into my quadratic equation. Y is equal to a, negative 1/2 x squared, plus bx, 2x, plus c, and c is equal to 0. So that's what I think we should get. Let's see if we solve this one correctly. Negative 1/2 x squared plus 2x. Excellent. Let's take a look at our second problem. Here is our second problem. So again, let's pick 3 points that we can clearly see, and then we'll build the problem from there. All right, so pick 3 points. So one point that looks easy to identify is when it crosses the y-axis at y is equal to negative 10. So first point I'm going to choose is 0, negative 10, y-axis intersection. Okay, and we can work through this one actually. Let's do this one first. So our x values are 0, so this term and this term goes to 0. So we're just left with c. Y is equal to negative 10 in this case. Sorry, I shouldn't write that. Just negative 10 is equal to 0 plus c. So c is equal to negative 10. So this is interesting, right? In the previous problem, we said when it crosses the origin, c is equal to 0. When it crosses the y-axis, we can even more generally say that value is equal to c. And that makes sense because when the a and b terms go to 0, all we're left with is the c term. So that's nice. All right, what's the second point that we can use? Well, it's not, the max and min is not on the y-axis, so it's gonna mirror. So I already have a -10. Let's see where it mirrors. That might be a nice point to choose. So this is at -3, -10. All right, so let's plug this into our quadratic equation. So y is -10 again. Ax squared, so a -3 squared, that's 9a, plus b times -3, so -3b, plus c, which I know is -10. Okay, great. Let's pick a third term. Maybe I'll use the minimum term here. So this minimum term, I don't want to reveal the solution just yet. So let's shift over here so I can read my values here. So what do I have? I have x is at -1.5. And y is at, these are at 1, 2, half increments. So that's -19. All right, so there's my third point that we can use. So let's take a look at what that point will give us. So we got -19 for my y term is equal to a times -3/2 squared plus b times -3/2 plus c, which is -10. Okay, so we can expand this. So we have something to work with. -19 is equal to 9/4 a minus 3/2 b minus 10. It might be useful, so I'll multiply everything by 4. I already have a 9a term there, so it might be nice to have a 9a term here as well. So multiply everything by 4. We get -76 is equal to 9a minus 3 times 2 is 6b minus 4 times 10, 40. All right. So let's see. Now I want to combine these two equations. I can subtract 2 and 3. -76 minus -10. Or sorry, I'm doing 2 minus 3. All right, so I'll get -10 minus -76. So that gives me positive 66. The a term drops out, so that's 0. Minus 3b minus -6b, so that gives me 3b. Minus 10 minus -40, so it's plus 30. So I'll get 3b is equal to 66 minus 30. 3b is equal to 36, or b is equal to 12. Okay, so hopefully that makes sense. And then the last thing, we could just plug in our final value. We can plug in b and c into equation, it doesn't matter which equation. Let me choose equation 2. So I'll get -10 is equal to 9a. I'm trying to solve for a term. I know it's going to be a positive value because of the shape of the parabolic graph right here. So it equals 9a minus 3b, which is 12, plus c, minus 10. All right, so let's clean this up. We got -10 is equal to 9a minus 36 minus 10. So 9a is equal to 36. So a is equal to 4. So if we plug this into our quadratic equation, we get y is equal to ax squared, so 4x squared, plus bx, so plus 12x, plus c, minus 10. Let's see if this one worked out correctly. We got 4x squared plus 12x minus 10. Great. Okay, so here we have our third problem. and I want you to pause the video. I want you to solve it on your own. And if you watched the last video, I want you to see if you can solve this problem using any of the methods we learned earlier, and the maximum, finding the max or min of video, which should be the video right before this one in the playlist. All right, give that a shot and then come back and we'll see how we can solve this together. All right, hopefully you had a chance to try out this problem on your own. So what can we say about C? Well, we can see that this graph crosses at, each of these are at quarter or half marks. So this is at -3. So at this point here, it crosses at -3. So C is equal to -3. And I know that if you want to plug it in, you know that this point is 0, -3. If you plug it in, you'll get C is equal to -3. So we can quickly just make that statement. The other thing we can see is this is a maximum. So I can use the derivative dy dx at the max x location is equal to 0. So dy dx is 2ax plus bx, or x at the maximum. What is x at the maximum? Well, that's just 0, right? Because it's along this y-axis. Oh, okay, sorry. This doesn't belong. I was trying to figure out what I did wrong here. So dy dx is 2ax plus b. I added the x term here, which is incorrect. All right, so x max is this location right here, right? This is your max at 0, -3. So that's where we got the C value is from here. And this is our x max. So 2a times 0 plus b is equal to 0. So from this, b is equal to 0, which is nice too. So, and this is a result of the location of this max component and what the derivative looks like. So this is really quickly we are able to solve for B and C. Okay, what do we do now? Last step, plug these into our quadratic equation. And what do we get? We get y is equal to ax squared, no b term, minus 3. So last thing we need to solve for is a. So we can find another point. Let me choose this point. Right here we have x is 1, y is -6. So let's plug that in here. What do I say? Y is -6, x is 1, and then what do we get? We get a is equal to -6 plus 3, so -3. So you can see how we can use certain tricks to speed it up, but if we don't know them, we can always pick these 3 points easily. So y is equal to a x squared plus b, which is 0, so I'm going to leave that term out, plus c. So you got y is equal to -3x squared minus 3. So hopefully you were able to get that. We'll work through more of these problems, and you'll see as we go through more of these videos some of the behaviors of these graphs and how max and min can be used to our advantage, and how crossing the axes and the origin can be used to our advantage as well.